Hello everyone, I'm Dr. John Siat Ling from FKE University Tun Hussein on Malaysia. Welcome back to ODE class. In this session, I will share with you a topic on non-homogeneous linear differential equation with constant coefficients using undetermined coefficient. The learning outcome of this video is you will learn step-by-step procedure to use method of undetermined coefficient. I also solve the second order non-homogeneous linear differential equation with constant coefficient by using method of undetermined coefficient for the fx is case exponent. In order to solve the non-homogeneous linear differential equation using method of undetermined coefficient, first of all, you need to know what is the non-homogeneous linear differential equation. This is the equation for the non-homogeneous linear differential equation in which the differential equation here is equal to the fx and this fx not equal to 0. So when fx not equal to 0, this is we call it as a non-homogeneous. Okay, what you have to do if you want to solve this kind of differential equation. First of all is we need to find the complementary function, that is the yc, for the corresponding homogeneous equation. Then we need to find the particular integral, that is the yp. And then followed by the general solution, y equal to yc plus yp. And lastly, we consider the initial conditions if applicable. Previous slide, I have shown you what is the fx. Fx is given by the question. And in this slide, I will tell you how to find the particular integral yp. First of all, you need to assume the yp based on the fx given in the question. And then you have to check if the yp have the same pattern with the complementary function yc. If yp equal to the yc, then you have to multiply the yp with the x. And if the same patterns occurs again, multiply yp with x again and again until the pattern is not the same. And that is your latest yp. After that, you find the yp prime and yp double prime. How to find the yp prime and yp double primes? Okay, if you want to find the yp prime, you differentiate the yp, you get the yp prime, and then differentiate the yp prime, you get the yp double prime. And after that, substitute the yp prime and yp double prime into the differential equation and obtain the value of c and d by equating the coefficients. This is the table of assuming yp. Fx is given in the question, and if the fx is an exponent case, example of fx is k exponent power of nx, the assumed yp is yp equal to c exponent power of nx. And if fx is a polynomial case, in which is a k, so the yp is equal to c. And if the fx is kx, the yp is cx plus d. And if the fx is kx power of 2, the yp is cx squared plus dx plus e. Okay, and if the fx is a trigonometric case, either is a sine or the cosine. For example, k sine nx or k cos nx or k sinh nx or k cos nx. This is the yp. You assume the yp is equal to c cos nx plus d sin nx or yp equal to c cos nx plus d sinh nx. Let's look at the example. Find the general solution for y double prime minus 4y prime plus 4y equal to minus 4 multiplied with exponent power of 2x. This is the case exponent. In order to solve this question, first of all, we need to find the complementary function yc. The differential equation for the homogeneous part, that is y double prime minus 4y prime plus 4y equal to 0. And we can characterize this equation into m squared minus 4m plus 4 equal to 0. And we can factorize it. we can get m minus 2 and m minus 2. So the m is equal to 2. Based on this m value, the m is equal to m1 and equal to m2. So it's a real number. So the y-x is equal to a plus bx multiplied with exponent power of 2x. The second step is to find the particular integral yp. Fx given by the question is negative 4 exponent power of 2x. This is the case exponent. In order to find the yp, we can assume the yp from the table of assuming yp. Since fx is the case exponent, the assumed yp is c exponent power of nx. And this nx we can refer to this 2x. Therefore, we obtain c exponent power of 2x. Next, we check either the yp same as the yc or not. From the previous slide, we know that yc is equal to a exponent power of 2x plus bx exponent power of 2x. And then we check this yp same as yc or not. Yp equal to c exponent 2x and yc is a exponent power of 2x, means it's the same. If it is the same, we have to multiply the yp with x, and then we obtain cx exponent power of 2x. And then we repeat the same procedure. We check again whether this yp same as the yc. Yp equal to cx exponent 2x and yc equal to bx exponent power of 2x, means it is the same. So we need to multiply the yp with the x again. Therefore, we obtain the cx squared exponent power of 2x. And then we check again with the yc. Now, the yp is not the same with yc. So this is the latest yp. Step 3 is to find the yp prime and yp double prime. From the previous calculation, we obtained the yp equal to cx squared exponent power of 2x. In order to find the yp prime, we assume the cx squared equal to u and exponent power of 2x equal to v. And then we differentiate both u and v. U equal to cx squared, u prime equal to 2cx. And v equal to exponent power of 2x. And we obtain the v prime equal to 2 exponent power of 2x. And then we use the product rules, that is yp prime equal to uv prime plus vu prime. We substitute all the value and we obtain this answer. Next, we find the yp double prime. In order to find the yp double prime, we assume the p is equal to cx squared and equal to p and q equal to 2 exponent power of 2x. We differentiate the p, we obtain 2cx, and we differentiate the q equal to q prime equal to 4 exponent power of 2x. We assume the r equal to exponent power of 2x, and we assume s equal to 2cx. We differentiate the r, we obtain 2 exponent power of 2x, and we differentiate the s, we obtain 2c. Again, we use the product rules. Yp double prime equal to pq prime plus qp prime plus rs prime plus r prime s. For the green highlighted answer is we substitute all the value of pq prime plus qp prime. Whereas for the rs prime plus r prime s, the answer is in orange highlighted. And then we group the coefficients such that x power of 2 multiplied with exponent power of 2x and x multiplied with exponent power of 2x and exponent power of 2x. This is how we solve the yp prime and yp double prime. From the question, we know that the differential equation is y double prime minus 4y prime plus 4y equal to minus 4 multiplied with exponent power of 2x. Then we substitute the value of y double prime, y prime, and y into the equation. And we get this answer. The orange underline is referred to the value of y double prime. Then blue underline refer to the value of y prime. And lastly, green underline refer to the value of y. We multiply in the value and we get the answer like this. Next, we compare the coefficients. Firstly, we compare the coefficient of x squared multiplied with exponent power of 2x. Here you have the value of 4c and another one also 4c. So 4c plus 4c is 8c, and then minus with the 8c, so we can cancel out. Next one, we compare the coefficient of x multiplied with exponent power of 2x. You have the value of 8c minus xc, also cancel out. And we only left exponent power of 2x. At the left hand side, we have the value of 2c, and at the right hand side, we have the value of negative 4. So c is equal to negative 2. Then we obtain the particular integral yp, that is cx squared exponent power of 2x. From here, we can substitute the value of c is equal to 2 into the equation. And last step is the general solution, that is y equal to yc plus yp. And then we just substitute the answer. That's all for this question. Hope you can understand. Next session will give you another example on this subtopic. See you then. Bye. Thank you.